So the two that we did together in class yesterday, one of them was finding an angle, if you remember that, and we reviewed how you find an angle on your calculator with trigonometry. It was tangent, it was shift tan bracket something divided by something equals, or if you have a different calculator, it's a bit different. So we did one finding an angle yesterday, and then we did one where we were solving for a side length, but the unknown was on the bottom. Those are two of the types of trigonometry, sort of basic types of questions that we come across in SOHCAHTOA Trig. And if you remember way back near the beginning of the course, when we first saw SOHCAHTOA, one of the things we talked about is there's sort of three types, right? Looking for an angle, x on top, x on bottom. And you have to know how to set up each type, how to solve each type, how you rearrange, how you punch it into your calculator, where you put the x, all that stuff. So again, if you're trying to review this and think about how to solve it, those are the questions you should be asking yourself. What type is this? How do I rearrange? How do I punch it into my calculator? Am I able to do it? Do I need help? Do I need to ask somebody to show me how to do it? That kind of thing, right? And if you're ever in doubt, everything's online. Like we wrote it all out, so go in the classroom and find it, or one of these examples that we're doing over the course of these couple of days. But that's one of the things you want to be thinking about. And then the other steps, labeling the triangle. When it's an application like this, you have to draw the triangle and label it properly, but then label it with hypotenuse, opposite, and adjacent, pick the right ratio, that kind of stuff, right? Those are the other steps that are involved in trigonometry. So let's take a look at this one. This one's really straightforward. Ava's town is having a contest to find the tallest tree. Measure the height of a pine tree on her family's farm. She goes to the base of the tree and then is able to measure, walking exactly 15 meters away from the base of the tree. Some people are very good at drawing diagrams and visualizing these things. Other people have problems. So watch carefully. I'll try to show you some strategies about how you can do it. Think about the tree and the base of the tree. So a lot of people like to draw a tree. It's fine to do it. It's not wrong. But if it complicates your diagram too much, maybe don't actually draw in the things, or draw it, but then draw a separate diagram that you label properly. So she walks 15 meters away. So that means this distance is 15 meters. In the tests that we wrote, people were labeling things wrong. Like people were labeling shadows in the wrong place and putting measurements in the wrong place or X in the wrong place. Drawing a proper triangle and labeling it properly is a big part of it. So that was similar to triangles. This is trigonometry, different, but they're same in terms of how you're labeling and thinking about this stuff. Okay? Yep. This is one of the ones that you were supposed to do after. Questions 2 and 5. 2 and 5. 2 and 5 were the ones that I said. Anyway, we don't need to talk about that right now. So then you have your tree. That's where she started from. Okay, and there's the top of the tree. How tall is the tree? So that length is the X that I'm looking for. And then another thing that some people are having problems with is like the difference between a length and an angle, like which one's which. You cannot switch those things around. So if it tells you an angle, you can't, like 65 degrees, you don't put that as a side length. What is a measurement of an angle? It's how far something rotates away from something else, from a pivot point, right? So something that's interesting is if this angle, remember we estimated angles yesterday, what does that look like? 40, 30-something degrees, 37 maybe. Let's say this is 37 degrees. The distance between these points is very different from the distance between those points. An angle doesn't measure distance, a length. An angle is a measurement of how far you've rotated on a pivot point. So no matter where I measure from, these two lines are 37 degrees apart, but the actual length is different. Okay? We'll finish our triangle. Because we're talking about triangles, it's a good idea to finish it again with the similar triangle stuff. Some people didn't actually draw a triangle. They only drew sort of part of it, which doesn't mean you got the wrong answer, but it is important to show it as a triangle. We like to show the right angle. I've got X, I've got 15. The last thing that I'm doing is she measures the angle of elevation from the ground to the top of the tree as 65 degrees. And some people, again, have a problem with this. So how do I know where to put the 65? Anybody? Summer. Why would you say the top corner? The ground to the top would be like a length. What angle? So you're talking about this. From the ground to the top of the tree. But isn't that like from the ground to the top of the tree would be that angle? Between the ground and the top of the tree. So, and also the other thing that we talked about a lot is, where could Ava actually measure an angle? Like, she can't measure this angle up here unless she climbs to the top of the tree. She can't measure that angle. So it should be this one, which is 65 degrees, and my triangle is not perfectly drawn to scale because I drew the triangle before I looked at the angle. But it's good enough for this one, but whoops. Maybe you would draw your triangle a little bit more like that. If it's a bit more to scale, it helps you. So again, you're not going to get marked wrong, but it helps you. In particular, we saw the one yesterday with the airplane. You wanted to draw it to scale like that with a very small angle so that you could think about where the angle goes. Like, that's really important. But in this case, okay, so we got it. So now what do? Now my triangle's drawn. I can forget about the fact that it's a word problem. And I can just say, find x using SOHCAHTOA. Okay? How do I know it's SOHCAHTOA and not similar triangles or Pythagorean theorem? Very good. So it's not Pythagorean theorem because that would be two side lengths to find another side length. You would need the hypotenuse, so you need to be looking for the hypotenuse. It's not similar triangles because there's not two triangles. Okay, try not to get those things mixed up. Think about when you use which type of skill. Trigonometry, because I have an angle and a side length. And trigonometry, SOHCAHTOA, is what mixes angles and side lengths together, using both to solve for answers. So in this case, here's my hypotenuse. Across from the angle that I'm going to use or that I'm looking for is opposite. And the last one is adjacent. So I know adjacent and I'm looking for opposite. Well, that's tangent. Tan theta is opposite over adjacent. Tan of 65 degrees is opposite, which is x, over adjacent, which is 15. And this is the third type that we didn't see yesterday, where x is on top. How do you solve it? Well, this is just like an equation with fractions. I multiply both sides by 15. So those divide to 1 on that side, and I get 15 times the tan of 65 equals x. And you certainly can't do this kind of math in your head, so you need your calculator. You need to know how to use it. And I get 15 tan 65. Let me see if my scientific calculator works. So on this one, it would be, if you have a two-line calculator, it would be 15 tan. Make sure it's in degrees of 65. Let's see if this works. I haven't used this calculator very much. 32.16. So x equals, how tall is the tree to the nearest 10 centimeters? That just means one decimal place. 32.2 meters. Therefore, summary statement, the tree is 32.2 meters tall. Properly labeled diagram, how to set up your equation to solve, but it's an easier one than some of the ones we've seen, but it's a nice one to just show how do you solve, review how to solve SOHCAHTOA, a trig question with x on top. That's the third type that we haven't seen. Questions about that? We're going to do one more. Together, and then you're going to do a few on your own. Oh, let's check our answer here. So 32.2, nice. Question 5. So this one was tricky. Again, people having trouble visualizing it. So that's part of what we're practicing right now. It's how to just read through the question and understand what it's saying. So a hiker can see a tower due north of his position. Now, which direction you call north, east, southwest, I don't care too much about that. So if you did that wrong, like if you got east and west mixed up, you wouldn't lose marks. Okay? But you do need to be able to think about those relationships to some extent. So there is a tower that is directly north of him. So that's the first tower. He can see another tower, and he happens to know that it's directly east from his position, and it's 5.0 kilometers from the first tower. 5 kilometers due east of the first tower. So east and north are at right angles to each other. That's telling me the right angle. Using a compass, he faces the first tower, and then he can measure that he turns exactly 52, or about 52 degrees, until he's facing the second tower. So there's your angle. So now I've got a side length and an angle, and I can solve for other stuff. How far is the hiker from each tower? So that's asking for lengths, for distances, for X and Y. I labeled those two. Labeling your unknown is not only part of your full proper diagram, it's also a really good strategy for you to think about what you're solving for, what you're trying to find. It focuses what you're doing, okay? So it's a really good idea. Like if you're ever stuck, where do I put the X? What am I looking for? Where is it in my diagram? So let's pick one. We'll start. We've done a little bit of this where we solve for two different things in the same question. So we'll start with X. You want to be clear about which one you're solving, not just for the people reading your work, but for yourself. So you can go back and look at it. So this looks like from 52, that's opposite, and this is adjacent. So that's tangent again. So tan of 52, opposite from 52 is 5.0, and adjacent to 52 is X. So this is the other kind with X on bottom. How do I solve this one? Jake? Awesome. Nice. Yep. And so you're dividing. So I get, whoops, I need the numbers here. 5. So 5 divided by tan of 52. And that gives me 3.9. So I found that distance to be 3.9. And now I'm going to do Y. And Y is, again, opposite and hypotenuse this time. So I'm looking for hypotenuse, and I know the opposite, and I've got an angle. So opposite and hypotenuse, well, that's sine. So sine theta is opposite over hypotenuse. Sine of 52 is opposite, which is 5 over hypotenuse, which is Y. Whoops. Oh boy. 5.0. And same kind of question where they trade places. So Y equals 5 divided by sine 52. They look very similar, right? These two look similar. Just one has sine and one has tan, and that will make a difference in the answer. That's what sine, cosine, and tangent do, okay? So even though everything else looks the same, there'll be definitely different answers. 5 divided by sine of 52 gives me 6.3. So the hiker is 3.9 kilometers from the first tower and 6.3 kilometers from the other tower. Anybody explain why that answer makes sense? Like when you think about those answers, remember this is something we talked about all semester, is like take a moment and think about, does your answer make sense? Yeah, very good. Y has to be the longest, 6.3. They're all in the same ballpark. 3 and 5, like, or 4, just about 4, almost 4, and 5 and 6. I didn't get one that was like 25 kilometers or something. That wouldn't probably make sense. So they're all in the same ballpark. Hypotenuse was the longest. If I did it the wrong way, if I did 5 times the sine of 52, I would have gotten 3.94. So that would not have made sense. And I could have said, wait a minute, how can the hypotenuse be smaller than the 5? Wouldn't make sense. Right? So think about your answers as you're working, and it can help you catch mistakes.